I'm sharing my screen. Please let me know once you see my screen.
Yeah, it's visible.
All right. Okay. Okay. As part of this, we'll be covering many tools are available as part of DevOps and DevSecOps. So probably I think I'll just brief you about what is DevOps and what we are going to cover in an overall course. So this probably I'll take it up at the end of the session so that you can understand few concepts, because there are so many concepts here based on the tools. So basically, what is DevOps and why do we need DevOps? So there are so many concepts and tools to learn as part of this course.
Sir, your voice is very breaking.
Oh, is it? Is it clear now or still?
Yeah, yes, sir, clear.
It's good for me.
Okay. Okay. If you take any project, there are majorly two teams will be there. One is the development team, another one the operations team. For any application, these are the major two teams, right? So DevOps will actually fit in between these two teams, and it will give a handshake between the development team and operations team. So that's where the DevOps will play the major role, right? So if we take there will be two teams, right? Basically, if you see development team and there will be operations team, right? Development team will be doing the development and operations, right? So the DevOps actually will play the major role by connecting these two. Right. So generally, if we check development team will develop they will write the code and in a different languages, and they will use the different tools, right? And there will be different programming languages also, right, where they will be using. So for this, they need to maintain the source code in a some place which we call it as repository, right? So what is repository? So we'll be covering, and the major tool which we'll be using for the source code management will be the Git. The majority of the projects and companies, they are using the Git. Git has again open source as well as the paid version, I mean commercial version, enterprise versions. So based on the requirements, we can choose the tools. So we'll be covering the Git as part of version control. This is what we will cover majorly in this entire course. The first part will be covering as source code management, which is Git, GitLab. There are many other tools, but as part of this course, we'll be covering the Git and GitHub, right? Once the development is done, they need to deploy into the different servers, right? So for testing or the pre-production servers, there will be many servers where we need to test the application before giving it to the customers, right? So so as part of this source code management, so we will not be a DevOps engineer will not be writing any source code, but what he need to understand is how the developers will work, which Git flow they will use, and how the application is configured, and how the testing or automated test frames are. There will be different tools based on the projects, right? So how they will be using the tools and automated test frames. So why we need to understand these concepts is, though we are not writing the source code, but we are the one who will create the bridge between the development team and the operations team. So that's why we need to understand the workflows, what workflow they are using, or there will be different branching strategies and which branching strategies they'll use. So that will help us in creating the CI/CDs pipelines. So what is CI/CD? Continuous integration and continuous deployment. So what does it mean? So if we take the old model, which I think most of us learn waterfall model, right, as part of our academics. So waterfall model, what it does is there is no connection between the teams who are involved in the software lifecycle. So that's where the major disadvantage of that is that time. If you want to release a fix using the waterfall model, so there is a lot of delay. So once the development they finish the coding, they need to give it to the testing team. Then they will, once the testing is done, they need to deploy into the deployment servers or pre-production servers. So here it is like one way traffic. So there is no proper handshake, which will collaborate between the development team, operations team, and QA team, and the security team. There are multiple teams now, right? So there is no proper handshake. That's where the CI/CD will help to avoid those problems. So what is CI/CD? Continuous integration and continuous deployment. CI is continuous integration, CD is continuous deployment. What is continuous integration? See, developers, they will write their code, they will do their unit testing, all those things. Once that is done, they need to put it in somewhere, right, to test that. So if you implement the CI pipeline, we call it as pipelines, continuous integration pipeline, that will help to reduce that time for the testing and deployment. So what will happen by using the CI servers is, once the development is done, there are tools and pipelines which can be integrated for the source code management tool, which is Git or any tool. I'll talk about Git only in this. So we can integrate the CI servers or CI tools to the Git itself. What will happen with that? As soon as some code changes happens, automatically that will get copied into the CI server, and the testing, unit testing or deployments, whatever the testings as required as part of the project requirements. So that will get covered in a sequence mode without doing anything. It will be triggered automatically once your check-ins or everything is done into the source code. So what is continuous deployment? So there will be a few checks which will happen as part of CI process. That is kind of BAT, you can say, basic acceptance testing, before moving to the next level. So there will be a few test cases which will get executed. Once those are passed, we can write a conditions there. If these are satisfied, these are my conditions. If these are satisfied, then move it to the next step, which is deployment, CD, continuous deployment. So your artifacts will get deployed into the servers, required servers, that is CD. So for CI as well as CD, there are many tools which we are in the market right now. So we will be covering Jenkins as part of that. This is the majorly used tool again in the market. So don't get confused or bothered about there are so many tools, or do I need to learn all those things? No, nothing. Don't worry about that. So we will be covering the top tools which will cover most of the market in the industry today. So what is the advantage of that? The concepts are same. Maybe the simple installation, your what is that, name, logos will change. That's all. The most of the commands or concepts remain same as part of this source code or CSR and all the tools. Okay. And we'll also cover, see, if you want to do this CI/CD process, we basically need to understand Linux basics, right? So we'll cover Linux part, what are the different operating systems, what are the different commands, the Linux file system, server management, all those things also we'll cover. So we'll start from the scratch again, how to create a Linux system. We'll cover 2-3 flavors like Red Hat or CentOS or RHEL. So 2-3 flavors we'll cover. We'll start creating the servers and experimenting with that, and understand the file system, understand the security. So all those things will be covering, which is required to work on the CI/CD. Again, here also the basics are enough actually. So there are separate teams as part of DevOps itself. There will be a security team who will take care of security part. There will be admin team who will take care of administration part. So as a DevOps engineer, you should know the basics, which are minimal required, right? Once that is done, all these artifacts, once the CI/CD is done, so we need to put it into the test environments or artifacts, right? So for that, we will be covering Docker and Kubernetes. The present world is completely depending on the containerization. Now, no, most of the projects and teams are not depending on any of the old type of hardware maintenance and all those things, right? So earlier, if you want to create a small system or VM, so IT team used to contact IT team and they used to take 1 or 2 days to configure and give it to us. Now it will happen within fraction of seconds, and we can create on your own, and we can also schedule it based on our requirements. So that's where we'll cover Dockers and Kubernetes, which are like so we'll be covering Docker and Kubernetes, which will be like containerization tools, right? And we'll also cover Artifactory tools as Nexus. Why do we need Artifactory system? See, like any source code management, we have Docker and Kubernetes. These containers also we need to store in a repository. So that's where we will use the Nexus. So there will be a lot of images which we need to create as part of our day-to-day activities. Nowadays, it is not like olden days, right? If you take Amazon or Google, just imagine the number of fixes they will apply per day. It will be in lakhs. If you follow the old process, that deployment itself will take years for the lakhs of patches which we need to apply, and there will be a lot of downtime required. Definitely that is not acceptable with the present world. And today, if you see, everything is digitalized, right? So we cannot accept, our things will not work now if you bring it down the servers. Like earlier, you used to get a messages, right, saying that so and so application will be down for a certain time or maintenance because there will be patch updates or something will be happening. Now, without doing that, we can actually deploy the things without bringing it down. That's where the deployments as well as the pre-production tools will be useful using the Ansible, Puppet, Chef. These are the tools. Again, these are tools like minimum concepts, which we need to understand. The simple syntax will be there. Just add that like HTML kind of code. So which will be useful, which will be using the pre-production tools or deployment tools, all those things, right? So we'll be covering Ansible as part of that. And once that is done, everything is deployed right now. But the major thing is like, do we really need to sit and understand where the problem? Assume you have deployed an application into some server, deployment servers. Once you deploy into the server, so there will be a number of issues. There will be a number of services. If you take the present applications, not one server, it will not be deployed in a one server. There will be hundreds of servers where we will deploy the application, because that is called load balancing, which will cover that as well. As part of load balancing, there will be a lot of servers will go down automatically. So for this entire process, we cannot sit and monitor 24/7. So there are again tools for that. So which will cover under monitoring term, like Jabex, NegoS, Elasticsearch. We'll cover Elasticsearch as part of this course for monitoring tools. So basically, these are the DevOps tools which will get covered as part of this course. And we'll also cover the security tools at the every phase of the DevOps model. So in a source code management level, we'll cover the Fortify as a security tool. So before going to that, why do we need security? See, everybody is following the DevOps model, well and good. your applications are deploying in a fraction of seconds, which is good. But if you see the number of attackers in the present world, it is becoming huge and huge, because the data everywhere, every application is storing the data, right? So the data protection is very important. So once you release the application, if hackers attacked banking sector especially, right, so there will be a huge loss. And to fix that issue, we need to come back to the source code starting phase, plan phase. Then to complete that loss, it will take a lot of time. Actually, in one of the surveys, they have identified that the rework of these issues identified at the later stage is costing more than the developing a new project. So that's why if you start implementing the security from the starting phase itself, starting from the source code management, CI server, right? So it will add a lot of values, right? Ultimately, we'll end up delivering a more secure product. So there is a very less possibility of attackers getting into our application, since we have taken care of the security part from the initial stage itself, right? So that's where the security will play the major role. That's why we'll be covering DevSecOps. DevOps will cover the major tools in a pipeline manners, but security will cover the major tools as well as the strategies which we need to apply at the every stage of the life cycle, software life cycle. So source code management level, we will be covering the 45, which will be like source code scanner. And Coverity, node security or McAfee, Alameda, SonarQube. These are the few tools which we will be covering as part of this, and we'll cover why do we need all those things, all the tools, right? Is it clear? Am I fast, or is it okay to continue in this phase?
Yeah, we are good. But I have a couple of questions, Bhaskar. Shall I?
Yes, please.
Yeah. What's the difference between DevOps and DevSecOps?
Okay. DevOps is a subset of DevSecOps. There is no difference. Okay. So if we take this is the difference. That's all. If you see the first part, this will explain about DevOps. In a DevOps model, same as usual, your coding will be there, building will be there, testing will be there, delivery will be there. But there is no security integrated as part of this process, right? If you see that this picture, everything remains same. Your coding is there, building is there, testing is there, delivery is there, and the components are also remain same. What is getting added extra is at the coding stage, threat modeling and design review. At the compile time, static code analysis, right? So why do we need static code analysis? There are tools available. 45 is one of the tool example. So if you run the 45 scan, or if you scan your source code using the 45 tool or SonarQube, in any tool basically, right? So what it will do, it will identify all the loopholes of your source code. There are many, I mean, generally, right, there will be hundreds of developers. Everyone will not follow the standards or guidelines, right? And nowadays, most of them, including everyone, without Google, nothing will work now, right? So we'll just copy from the Google and paste it, right? There will be so many loopholes in that. So threat modeling, the static code analysis will help identifying those loopholes in the early stage itself before getting into the testing, right? So without doing this, if we give it to the testing team, if again in the testing phase also, if we don't do few specific testings, security testings, again we cannot identify those things. So ultimately we'll end up delivering those problematic applications, right? See, most of the time testing team will cover functionality side, stress testing or performance testing or functionality. These are the major things. So security wise, very few people will concentrate, because the world is now in a situation where the attacks are increasing a lot. So we have to take care of security testing as well.
So after this course, we will be called as a DevOps engineer or DevSecOps engineer?
DevSecOps engineers.
Okay, so from the previous slide, you're covering both the security part, which is the Sonar Cube, Fortify, and all. So by having those knowledge of those
See,
tools, we will be called as a DevSecOps team engineer.
definitely, see, the DevSecOps and DevOps, people are actually over a period of time, maybe down the 2-3 years, there will be only DevSecOps. You have to follow that. So I'm sure that will come, right? So by what is the advantage by learning your Sonar Cube or static code analysis tools? See, you will definitely have a more weightage when compared to other resumes, right? Ultimately, you will be a better resource than knowing the person who knows DevOps. DevSecOps definitely will be an added advantage for your resume. Definitely, it will give more weightage, and the recruiters will give the more value for this. Again, in this DevOps, see, there are different roles in this DevOps. There will be build team, there will be a deployment team, there will be a release team, there will be a security team, right? There will be an ops team. It's all depends. So see, after learning all those things, you will not be working in all the tools. So you'll be fitting in one of the tools, or I mean one of the teams, and you will be working in that area. It's all depends.
Okay.
Is
And
clear?
yeah, and also like when I was exploring something in Google, they say like DevOps, AWS DevOps, Google DevOps, or Cloud DevOps.
Right.
So what is that we will be called after this training? Will be called as a AWS DevOps guys or Google or
See, as a DevOps
which
engineer, again, as a DevOps engineer, so you will be covered. I mean, okay, as part of this, to answer your question, you will be called as AWS because I will be talking about AWS. Okay.
okay.
So again, there is no much difference between there are different cloud platforms. That's all. AWS is Amazon, GCP is Google, Azure is Microsoft, right? So they have their own platforms. That's all. So again, your services will remain same. Most of the services will remain same.
But
There
the
are only
government
few delta part which will be which are the differential factors between all these
so more
providers.
or less, whichever is the cloud provider, what the tools you cover, it's more or less the same they'll use in each of these cloud environments.
Your terminology will change, but your concepts remain same. So I will be covering AWS as part of this course.
Okay. All right. And DevOps is only applicable whenever there is a cloud concepts. If
No,
it's
no,
in
no, no. Again, your cloud is one of the component in the DevOps model. So earlier, what was happening is every company is to maintain the on-premises data centers. Do you know what is data center?
Yeah.
So where all the servers will be stored.
Right.
So there will be a single point of source where all the servers are stored. Why do they need to maintain the separate data center? There will be a lot of security reasons for that, right? So it will be easy for them to maintain the network switches, boards, everything. It will be easy to maintain that, right? So DevOps, as part of DevOps, AWS is one of the tool, right?
No, AWS is a cloud, right? How it becomes a tool?
Of course, this is one of, I mean, of course, it is a cloud data center. That is one of the data center. I'm saying one of the topic in the DevOps.
Okay.
Right. Okay. Let me show that to clarify your doubt. So these are the different course contents we'll talk about. We'll be talking about
Can you
software.
maximize this? Can you maximize this a little bit?
Is it okay?
Yeah. Yes. Better.
Okay. So we'll be talking about software development model. What is the development model as part of that? What was the waterfall model and what are the disadvantages? How the industry is moving from the waterfall model to agile, from agile to CI/CD, CI/CD to DevOps, DevOps to DevSecOps. At present, the DevSecOps is the top priority thing, right?
Mhm.
So we'll cover that. Again, operating systems, I was talking about different flavors. We'll talk about what is the CentOS, how to create different VMs. So you don't need to see for your experiment, you can use Vagrant. I don't know whether you heard about it or not. So you can create your own cloud. Example, it is not cloud, don't consider. I'm just to compare, I'm saying install the Vagrant and you can create your own different operating systems like Linux and OS or whichever this on your laptop itself, right? If you have example, if you I think you have done the course already, right? So AWS will have an easy to instance example, and similar way you can create your own instances here. We'll talk about Vagrant as well, not only the cloud. The source code management, will talk about Git and GitHub, and CI/CD Jenkins will talk about Artifactory, Nexus. See, this cloud will cover AWS. This is one of the topics along with other tools like. You got it? See, once you
Okay.
learn this, you can apply only as a cloud engineer. There's nothing wrong in that. Every company is following the now everybody is moving to cloud, right? There are so many advantages. We'll talk about more in detail when we cover the AWS. Okay, there are so many topics in that.
Okay. So irrespective of any of the cloud platforms, even
Mhm.
if I have local servers or data centers,
Right.
we can apply DevOps.
Of course, yes. The Vagrant will help in that. See, I mean, of course, you can use the AWS or Vagrant. I was just talking about just to compare. There are multiple options for you to learn and explore. AWS again, you can have a free account, which you can use it for 1 year. You can use it for minimal things. Again, there are limits in that.
Mhm.
Your number of CPUs, cores, and storage, all those things. Right.
And this DevOps concepts applies to any legacy systems or only the latest Java, Node.js, or .NET applications?
No, nothing like that. See, you can use it for, see, this is nothing to do with what source code your application is running. This is all about how you are going to see. This is all about once your source code is done, coding is done, your application will come out as one application or some binary or some format, right?
Mhm.
How you take it further after, right?
Mhm.
See, if you assume if you use C, you'll get some type of objects. If you use Java, you'll get some type of objects, right?
Right. Mhm.
So the deployment method will change. That's all.
Okay.
It is nothing to do. You can go ahead and apply for legacy applications as well.
Okay. And one more thing, when we, I mean, from the initial diagram, what you had in this MS Paint, you said a developer team and operations team,
Right.
and finally we are combining that as called as a DevOps team.
Right.
So is it mandatory that we need to understand a few of the application programming languages?
No, not required. That's what I was talking about. So you no need to write any programming language, right? So
Mhm.
ultimately, where your work will start is, if you see here, this is what I was talking. Different phases, right? This
Mhm.
is the DevOps phases. Your planning, coding, build, test. You will be involved in all the phases
Now, what type
as a
of
DevOps
coding?
engineer.
No, I'll be
Development team will be doing the coding,
okay. Okay.
right? So there are
Okay.
few build tools like Maven
Mhm.
and right.
Mhm.
If you are using example, I'm saying one of the example. See, development will what they do. They will write all the coding, right?
Mhm.
Once the coding is done as per the requirement, see, you need to do the build. There will be a source code. You will check out source code from the Git or whichever the version control tool you are using.
Mhm.
Check out in the sense just copying the source code from the repository to the build server or local,
Mhm.
right? Then there will be a few commands which you need to execute to generate the objects.
So
Basically, compile.
so my job as a DevOps engineer is to executing the commands which will compile and put it into the. I mean, see, you're saying like coding is done in some of the development
Developers, yes.
and
Developers
development
does the
kits or
coding.
something. Yeah,
Yes.
in the development kit.
Right.
And after that, for pushing that into Git repositories, we come into picture and we build some. We code something, some scripts there.
Right. Scripts in the sense, yes. Again, developer will give the again depends project to project, but most of the projects these scripts are maintained by the development team, because there are code level changes which has to be integrated with the build scripts, right? Config level changes. If there are anything specific to environment config level changes, we will own that as a DevOps engineer. But code level, no, development team will own for most of the projects. Assume that there is a Maven file, you will just trigger Maven or ant, build at ant, build is the command, there will be a build.xml file. So you'll go to that specific location where the build.xml file is stored. You will execute build command, right? Once you execute the build command, if there are any compilation issues due to the environmental errors, okay, we may have to check first from our end. Then based on the logs analysis, you will come to know whether it is the problem with our environment level, or is it something to do with the code level. Most of the times you will get the compilation errors, because once your setup is done, you are not going to touch every day, right? So your scripts, your CI/CD pipelines will take care of pulling the source code, merging it to the central repository or integration branches. See, there will be different branches. What developer does in general, they will be adding their source code into the private branches. Each developer will have their own branches. Once they are done that, there will be a review process, right? After testing. Once the review is done, then only we will allow them to check into the integration branch. There are few checks which will get filtered as part of integrating it to the integration branch. Integration branch is nothing but release branch, which will go to the customer QA and customer.
Okay.
Is it clear?
Yeah.
So overall, as a DevOps engineer, you don't need to code anything. You need to use the source code, whatever they are going to check into the version control tool, read that code, copy that code, use your build commands, and generate the artifacts or objects, move it to the deployment server. That's what our role.
Okay, can you explain me the flow here on the tools used? So first it starts with
okay,
Git only, you said, right?
I'll talk about that. Okay, this will explain that. Okay. So what will happen? Developers, they do the coding. Once they finish their coding, they have to check into the source code repositories, which is Git, right? So checking in is nothing but just updating their changes into the centralized repository, centralized place, you can say, central repository. Okay. Once they do that, there are pipelines. I think most of the projects have started following the pipelines, but there are still many projects which are with the legacy process following the waterfall model, right? If they don't have pipelines, you need to do the manual merge. Again, there are commands for that. There will be 5-6 commands which you need to execute that. Merge some source branch, again the target branch, developer branch, and integration branch, and some comment. Why are we merging it? Example and say, right? Once you merge into the integration branch, your integration branch is ready for the build. Build is nothing but encrypting your code and generating .exes or whatever it is, right? If you take Java example, that Java file will get converted into .class file, which will be in a non-readable format. That's what build does, right? Once that is done, your .class files are ready, encrypted basically, right? Encrypted files are ready. Once that is done, you need to bundle that. If you want to install some software, how are you installing it? You will download it from the Google, either in the form of .exe or .zip, right?
Mhm.
How are you getting .exe? You are getting as a single file, .exe file, right?
Right.
But when you install it, it will do a lot of things, extracting, so on, and you need to select the some location, all those things, right?
Mm.
So what is happening exactly? So whatever that encryption happened as part of build time, right?
Mhm.
Between source code and the CI server, there is a build. Okay. That is
Mhm.
again, okay, you can consider that is part of CI because it is part of Jenkins these days. Okay. So
Okay.
we
So
will be
building is
creating those
done through
EXEs.
Jenkins. You're saying like building of the code.
No,
in-
it through Jenkins in the sense you can pass the commands what are required to build your source code via Jenkins. That's all. It's a mediator. Jenkins will not do anything. Okay. You need to pass the commands through Jenkins. Why do we need Jenkins? I'll cover that as part of that. For now, you can just consider that it's a mediator between
Okay.
the source code management and the other stuff. All the
Yeah.
commands, you'll just pass it. That's all.
Okay. So let me reiterate what I understand. So I'm a developer. I build an application in a programming language in my local, and then I push it to GitHub. So from my local to put it to the GitHub central repository, in between DevOps comes into picture, and that is automated scripts what DevOps guy writes there. Is that correct?
Right. You can say that. Yeah.
Okay. Okay. And after that, if I have to build that into an executable file,
Right.
I pull from GitHub using Jenkins, and then I put it into a CI server or a pipeline.
Right. It is part of CI server.
Okay.
Using Jenkins only, you will pull your source code from the Git.
Hmm.
Once pulling is done, the next step again in the Jenkins will be the build or config change before building if there are anything. Once your configuration changes are done, then build it.
Okay.
Once the build is done, your objects are ready to deploy.
Okay. So then before building, where is that 45 been applied?
Which one?
You said 45 is like a scanner, right?
Yes, scanner. Because the source code is there, right?
Hmm.
There is something called parallel and sequential steps
No,
in the
my question
CI/CD.
is, I mean,
Yeah, I'm coming to that one.
yeah, in the flow, where is it fitting up? Whether it is between the
Yes.
local and GitHub or between GitHub and CI server?
I'm coming there only.
Yeah.
Right? See, 45 for 45 ultimately what you need source code, right?
Hmm.
Whether you pass it from your local server before pushing it to the source code, it is absolutely fine. It will scan, right? Before pushing it to the source code itself, from your local copy, you can give the source code and run the 45. But the best practice is implement as part of CI itself. How it happens, once your build is happening, there is no dependency between your build, generating your exe and testing. This 45 scanner can go in parallel, right? By the time you complete your testing, your 45 scanner results also will be ready. Assume that this will take 8 hours. Your Jenkins building, generating artifacts and testing, right? In this 8 hours, your 45 scanner also can be finished in parallel. You no need to wait for your test results. Once your test results are out, whatever the test functional testing or whatever testing you are going to cover, your scanner 45 security results are also out. That's why it is mentioned in parallel along with that in this diagram.
So running this Jenkins and running this 45 scan is the job of a DevOps guy.
Yes.
Okay, now I
See,
understand
again in
the role of.
Jenkins, okay, I think you will understand more once you understand the concepts. Okay. See, how it happens
Understand what is
is
the role of a
your
DevOps.
Jenkins is the server where you can call your 45 also. Your Jenkins is the tool where it will allow you to create multiple steps. Okay, that's what I was talking about, pipelines, right? In the pipeline, you can have parallel pipelines.
Okay.
Once you start initiating the build, the another pipeline, parallel pipeline, which will initiate the 45. Your build also will go and check out the source code from the GitHub. Your 45 also will go and check out from the GitHub. Ultimately, what is required? Your source code is required for the server, right? The Jenkins can be configured. There will be a master node concepts in the Jenkins. You can configure 10 nodes, which will like different servers, right? But your Jenkins master will be same, where you will execute the complete flow of your project. In one node is nothing but one server. Your 45 will run. In another node, your build will run. In another node, some other step will run. Things will get distributed across the servers.
Okay.
If there is no dependency. If there is a dependency, then the next step will wait for the previous step. Example, if you want to deploy your artifacts into the some server, right? What is required? Your build is mandatory for that. Once the build is completed, then only your objects will get generated. These objects has to be copied into the server. So without generating build, if you copy your objects, what will be there? There will be nothing, right? It will fail. So likewise, based on the dependency, you need to configure or you need to implement the logic, whether you need to run the job in sequential mode or in parallel. You got it? You're getting me?
Yes. Yeah.
So that's where the Jenkins is useful. That's why CI/CD server, continuous integration as well as deployment server, we call it as. Is it clear?
Yes.
Okay.
So after Jenkins, I mean.
Okay, we're talking about flow. So once the Jenkins, your CI/CD is done, so we'll be deploying into the test environment or pre-production environment, right? That will be like, again, that will be initiated by the Jenkins itself. In the Jenkins itself, one of the step I was talking about, example 10 steps, right? One of the step will be in a sequential mode. Once your objects are ready, go and deploy into the so-and-so servers. Again, this will go in parallel. Once this is done, few steps from third step, again things will get distributed. First step, go and deploy into the QA server. Second step, go and deploy into the pre-production server. Third step, go and deploy into some other server, security server, right? Again, your jobs will get distributed here based on the dependency. So once that is done, again, for this we'll use the most of the projects will use the containerization platforms, which will be Docker and Kubernetes. So these different images will get stored into the Artifactory servers, like example Nexus. Consider that Nexus is again one of the version control tool, kind of version control tool, where you will get all your images. This Docker, what we call as images will get stored into that. Again, if you want to go back to the previous image, you can always use repository and copy paste that. That's where the Artifactory system will work. See, sometimes what will happen, you will develop something, you will deploy, but there will be major issues, right? If you want to fall back to the previous one. So again, you need the previous versions, right? That's where the Artifactory system is available anytime to fall back to the previous versions. You can pull that previous images and run it. Is it clear? So testing part, see, creating 10 physical servers is really a headache thing in the present technology, right? So that's where the Dockerization is useful. Say fraction of seconds, your Jenkins initiating one job will go and create one server on the fly within fraction of seconds. It will create the server, it will modify the configurations based on your prerequisites for this project or for this module, and it will go and copy the objects, then it will run the tests. The testing part is clear?
Yeah.
So
GitHub is a repository which has a source code understandable by the human, and JFrog and Nexus is an Artifactory tool which has an executable code understandable by the machine.
yeah, Artifactory systems, you can say.
Okay, so
repos.
when it is running from these repos, it will be pulling the code, or it's just like, I mean, it's
Code
a
is done.
repository.
Code is done before the CI/CD itself. These are all your artifacts, right? Objects, images, right?
Okay.
That's why I was talking about images, which is bundles,
Got it.
packages.
So these images are, I mean, once someone is invoking your program or your application, that executable file is pulled from these artifacts. Is it correct?
Yes, we'll store it. Basically, it is a you can say storage.
Storage.
You can say storage.
Okay.
Okay. Once that is done, the pre-production or deployment. See, assume that. Okay, I'll give you one example. There is a patch, security patch. So if you take any project, right, there will be thousands of servers. Tell me how much time you need to deploy a patch into the server. Assume you have 10,000 servers. Each to apply a patch, it will take 5 minutes. 1,000 into 5 minutes. How much time is required? It will be huge, right?
Yeah, 5,000 minutes.
Right. So that will see there will be critical patches where you need to deploy, or same thing, servers also. Say, take the example of your Amazon. There is a sale going on. See, they really don't know how many customers will come and try for or they will try to purchase. So that time there will be lakhs of servers they need based on the load or the requirement, right? So they cannot go and someone can go and sit. They will take 10 minutes for each server to bring it up. They will lose lots of crores of money in that, right? If application is not available. So that's why these Ansible, Puppet, Chef, these are the deployment tools, you can say. Okay. So there will be playbooks in this. Okay. So what happens? You can write a playbook which will go and deploy in all the 1,000 servers. You can mention the IP ranges from 101 to 1,001. Go and deploy. This is the one. Within fraction of minutes or seconds, it will go and deploy there. Again, simple syntaxes will be there. Don't worry about that.
So your 5,000 minutes work is being done in 5 to 10 minutes.
10 minutes. Yes, using this deployment tools, Ansible or Puppet. Basically, you need one-time effort is required for all these things, right? So you need to configure that. You need to write your playbooks. You need to write your servers list. All those things. One-time effort. After that, your things will go smoothly. Okay. Then monitoring part will come. So again, this entire process will get monitored using some tools. So what will happen? The entire system will be monitored, all the logs. Basically, we'll link all the logs to, we'll pass all the logs to Elasticsearch. Example, I'm giving one of the ELK stack, you can say. Elasticsearch is nothing but ELK stack. Then their name change now. So we'll pass all the logs. So that will give a graphical representation. You no need to go and sit, analyze all 1,000 system logs. So there will be a single place where you have a dashboard. You can just check and you can create alerts. If something goes wrong, just alert me. Instead of getting 1,000 mails for every system, if there is something really going wrong, then alert me. So that way, conditional based notifications and all you can configure. So your monitoring part will help in that way. Is it clear?
Yeah, understood. But where is this Coverty node security project, McAfee, Palmedia applied? SonarQube. In what stages this gets applied?
Okay. You take McAfee example. This is again at every fate. Coverity again is one of the monitoring tool. Sorry, scanning tool. McAfee example, if you take, once your artifacts are ready, right, or you can testing itself here itself in the testing phase. What does McAfee do? Do you know? You have laptop, right? You have some virus in your laptop. So what does McAfee do? I think most of the laptops will come with McAfee these days. Do you know what exactly it is doing?
Scans the storage, the
right.
And
Right.
if virus found, it gives an alert, and it says like these files infected. Do you want to quarantine? Do you want to delete? Is what I understand.
Right. There will be a vulnerabilities in the objects or code. Right.
Mhm.
Vulnerability in the sense users can hack those things by using these loopholes. Right. If you don't scan before putting into the production server,
Mhm.
your objects, example, .exe file is there. If you don't scan, assume that there is a vulnerability. So ultimately, you will end up delivering your vulnerable code to the customer. Right? It will scan the object. Right? Fortify will give you the source code analysis, which will be like static code analysis. Example, we can say static code analysis. So what it does, it will tell you the drawbacks of your code. Okay.
Okay.
The example, the once your coding is done, your build will happen. You will before deploying or before moving into the Artifactory system, McAfee will scan the bundles, packages, or exes, .exe files, right? And it will tell you in case of any vulnerabilities are there. Palameda is used to scan the open source scan. See, if you take any project, there will be a proprietary code as along with the open source code. So open source code we really cannot trust these days, right? Anyone can inject anything. So that's where the Palameda is useful. SonarQube again, which is equal to Fortify. Why we are using different tools? Fortify example, Fortify will not support your C language or TAL, right? So you need to use different tool. So based on your requirement, these tools will get fitted. But ultimately, these are the security point of view. You'll get your source code and objects will get scanned before putting into the production. Why we are in SonarQube, why Palameda, why McAfee? Again, it depends on the coverage. Fortify again licensed. Example I'm saying. SonarQube is not, it's a free version. So it will cover all latest tools like your Python, C++, Java and all. Right.
Mhm.
Coverity will be like all legacy languages, TAL and all. It will be used for Coverity. Right. Node security again like your McAfee.
Mhm.
Right.
Okay.
Is it clear?
For me, yes. Thanks.
I think with this, thanks for your questions. We covered, I think, flow as well in that. Okay, these are the topics which we'll be covering as part of this, and we'll be covering cloud as part of cloud. We'll be covering AWS for the entire course. We'll talk about all different types of cloud computing and what we are going to cover in this. With this, I think I will close this session. From tomorrow, we'll start with the Linux basics, creating
Sir,
hello.
sir, as I'm a fresher, this course is useful for me, sir.
Yes, definitely it is useful.
Yeah, I'm pursuing an MBA, HR and finance, sir.
Okay.
So I'm asking for you, sir.
See, that's what the present market is looking for the fresh engineers as well for the with the basic trainings. Majorly
Okay.
where they will fit in is either AWS cloud platform. See, cloud
Okay.
and all is like there is a predefined values. So based on your requirement, you can create your instances. There will be a monitoring also. You need to monitor the different roles where the freshers also will fit in.
Okay.
In the initial stage of Git and Jenkins, there are also a lot of freshers who can manage. There are a lot of things to do. I
Okay.
mean, you don't need a lot of experience to do those jobs.
This is best course, sir, as per freshers.
See, freshers, it all depends on where you are interested, but in the market, this is the topmost course or most wanted course now. Every company, every project is moving towards DevOps and DevSecOps models.
Okay, sir.
How is the market open?
DevOps is the highly paid roles these days.
Okay.
You can check who is getting more salary in the software industry. That will be DevOps and DevSecOps. You can say SRE also, site reliable engineer. Again, it is part of kind of DevOps. That again, work will be different. That's all. It will be more ops work. Site reliable engineer, SRE. If you learn DevOps, you can also work as a SRE.
Okay.
Any other questions?
Okay, thank you, sir.
Yes,
No.
sir. I'm having one question.
Yes.
Sir, as I've already covered the AWS topics, some services I've already covered, and
Okay.
I'm going to cover this DevOps also. So, after completing these both courses, do we need to go through with some database things like SQL or anything else like that?
So I'll be covering MongoDB. Again, if you see present, everybody is preferring NoSQL database, right? And you don't need prior experience to learn that. So it is easy to learn MongoDB, which will be
Okay.
useful for one of the other places in this DevOps process.
Means in the
It's again
current.
added advantage. It's not mandatory, but it is good to know. So that's why we'll cover MongoDB.
Okay. Fine. Thank you.
At what time is the trainings happening? Is it the same time every day?
8 o'clock, yes.
Okay. And do we get this recorded session, sir?
Yes, you will get. We'll be sharing the all the details, recording sessions along with the course content. Everything you'll get the details. We'll create account and we'll share the details. From tomorrow, we'll start the course content. We'll start with I'll cover a Linux part for few sessions. So as part of that, tomorrow I'll not talk about in detail AWS. Tomorrow we'll just create an EC2 instance, how to create EC2 instance and how to use that. And we'll talk about file system, Linux file system. Because Windows, already you must be using your laptop, so that is more than enough. But definitely Linux basics are required. So we'll cover one or two flavors. And we'll start from the scratch, creating a Linux server.
Okay.
Yeah, once Linux is done, we'll start with Git. After Git, we'll start with Jenkins. Once Jenkins is done, we'll talk about some repository tools, then AWS. And then once AWS is done, then deployments, how to deploy, all those things, then monitoring.
Okay.
Okay. Any other questions?
How long? What is it? How long? Duration of this course?
It will be 2.5 months. Present. If we cover security as well, if you don't cover only DevOps, will be 2 months.
Okay. Sure. Thank you.
Yeah. Thank you. Thanks for joining the course. So we'll meet tomorrow at the same time.
Is this your number, Sultan? We need to send you the email address, right?
Right. Please share the
Yeah,
details
this is
with
institute
Sultan.
number. Yeah. This is your institute number. Please send all of your email IDs and contact numbers. I will share with demo section. Okay.
Sure.
No.
Thank you.
Thank you. Thanks.
Thank you.
Bye-bye.